All right, let's move into some word problems now for 5.4, where we're solving for an unknown in a proportion. So for this example, we have a scale on a map, which is 1 1/4 inch, or sorry, 1/4 inch equals 3 miles. And the distance between two towns is 4 inches on the map. We want to know how far apart the two towns are. So when you go to do these word problems, you have to be careful that you're using a consistent measurement. So if 1/4 inches is 3 miles, we're saying like the distance on map over actual distance. Okay, so on the map then, that's this first one here, we have the distance on the map was 1/4 inch over the actual distance that represents is 3 miles. And we know that proportion is going to be equal to, and then this is like our, okay, I guess I should say scale on map. So this other one then is between the towns. And so between the towns, we have 4 inches on the map, which represents an actual distance of X. So X is our unknown here. And maybe you've done this in the past on a map where you've tried to figure out what the actual distance might have been. So we're going to do the cross product. Okay, so we get 1/4 times X equals 3 times 4. Okay, we can do that multiplication and we'll get 1/4 x equals 12. And now we've got 1/4x or 1/4 x. We want to eliminate that fraction. So remember, to eliminate that fraction, we're going to multiply by its reciprocal. So here we're going to multiply both sides by 4/1. That way we can get just a plain x. So x here on the bottom equals 12 times 4/1, which is 48. So that means the actual distance, and there should be a sentence here, so let's write the sentence. The actual distance between the towns is 48 miles, because my actual distances were listed in miles. Okay, let's try another example. So in a shipment of 400 parts, 14 are found to be defective. We want to know how many defective parts should be expected if we now have a larger shipment. We now have a shipment of 1,000. Okay, so again, we want to make sure we're consistent. And so in this case, it's been set up for you. So they've put the defective parts on the top in the numerator over the total parts on the bottom. So just remember that both of your fractions are defective over total. So defective over total equals defective over total. So in this case, then, we get 14 defective parts over a total of 400 parts. And we know that that's going to be an equal proportion, so equal to some unknown amount of defective parts over a total order of 1,000 parts. So now we have this proportion set up. Let's do the cross product here. And so we're going to get 400 times x, or 400x, equals 14 times 1,000. Okay, so we can do that multiplication. 14 times 1,000 would be 14,000. And now we want to figure out what just one x is. This is called isolating the variable. So we want to figure out what just one x is. We know that 400 x's equals 14,000. So let's divide both sides by 400. Because we know if we divide by that number, our 400s are going to cancel here, and we're left with just a plain x. So x equals 14,000 divided by 400. And what is that? I'm going to use my calculator. And I get 35. So then we can say 35 defective parts would be expected. Are expected. Okay. So give this video a pause and try the next few. You might as well. So see if you can do from B through F and then come on back and we'll do them together.